Hey guys, it's your last day of Try 2. We're going to do our last review lesson. This is going to be about unit rates and proportions. So our investigation says Ms. Taylor is going for a run and covers 3 and 1/4 miles in 2/5 of an hour. What distance in miles does she cover if she ran that speed for 1 hour? So I have my annotations here. I have the rate that I'm given, and I know I'm trying to find distance in 1 hour. So I'm going for miles per hour. I wrote that down because once you know what unit rate you need, that tells you the order to divide. So miles per hour, I'm going to do miles divided by hours. Again, I just got these numbers from my unit rate. With this 3 and 1/4 though, I can't divide fractions unless I have improper fractions. So I'm going to create an improper fraction. 4 times 3 is 12 plus 1 is 13. So I have 13 over 4. Divided by 2/5. Divide fractions, I copy, dot flip, or multiply by the reciprocal, and then multiply straight across. 13 times 5 is 65. 4 times 2 is 8. And then I need to make this number back to a mixed number. So I'm asking myself, how many times does 8 go into 65, or I'm dividing. I know 8 times 8 is 64, and I have 1 left over. So my final answer in miles per hour is 8 and 1/8 miles per hour. All right, so we're going to use that to fill in our key points. First thing we did was we annotated, or we used our func strategy to decide which unit rate, or if you have more than one, constant of proportionality you need. Proportionality. Good. Basically, you're saying, is it miles per hour or is it hours per mile? Look for the number 1 in your problem. If we look back, we had 1 hour. That's how I knew per hour. That's how I knew it was miles per hour. Next thing we did was we had that 3 and 1/4. It was a mixed number. We changed it to an improper fraction. Then we didn't do this in our investigation, but if we had something with a constant of proportionality, we would divide, and obviously for our unit rate, we divided as well. Next thing, if we have multiple unit rates, we're going to have to compare them maybe. And then over here it says to make an equation, remember it's always going to be y equals something x. This something is your COP. So COP, whatever that number is, just plug it in. Y equals COP times x is your equation. Okay, so for our guided example, we have a couple different types of proportions that we're going to see. Is it proportional or not? We have a graph and we have a table. So here we go. Gabe and Harrison are planning a road trip for their 10-year high school graduation party. Gabe's car's speed is represented by the graph on the left, so I'm going to say this is Gabe. And Harrison's car is the table on the right. Use the graph and the table to answer the questions. Based on the table for Harrison's car, are the miles driven proportional to the time? Show your work or explain how you found your answer. If the relationship is proportional, express the relationship as an equation. So I'm looking for, are the miles driven proportional to the time? And then if yes, I have an extra question. So let's decide, is it proportional? If you look back to our key points, we're finding a constant proportionality to see yes, it is proportional. In order to do that, I need to look at miles per hour. So we're going to divide y, miles, divided by x, hours. 0 divided by 0, not super helpful. 55 divided by 1 is, I'm going to make a table here for COP. 55. 110 divided by 2 is 55. 165 divided by 3 is 55. You'll notice I'm checking all of them because they all need to match. 220 divided by 4 is 55. 300 divided by 5 is 60. So, is it constant? I think not. We have 160 and a bunch of 55. So, are the miles driven proportional? No. There's a 60 instead of 55. And please make sure you have this work up here. That needs to be on your paper so that you can see that you're testing each one. All right, so Harrison we know is not proportional, but on the graph for Gabe's car, are the miles from proportional time. So same question, show or explain if you found your answer. If the relationship is proportional, express as an equation. On a graph, I'm going to see if I can zoom in. Nice. Okay. On a graph, there are just two things that we need to decide, is it proportional? It has to be a straight line. If I look at this line, yes, it is straight. It's not like doing anything like this, none of that. It is a straight line, that's good. It also has to go through the origin. The origin is the corner 0, 0, and it looks like, yes, it does. So this is proportional. And again, our reason is it's a straight line. And it goes through the origin. Or you can say it goes through 0, 0, if you like to show points. Okay, now the question says, if the relationship is proportional, which he just said it was, express the relationship as an equation. So we know that we have y and x, and our key point said we just have to do y equals COP times x. So to find COP, I'm going to pick any y value and divide by any x value. Let's see. You can pick whatever number you want. I don't see one that I see like a point here. I see a point here. You could pick any of these points that I'm showing because these are like the most obvious ones. I like this point. So we're at 1 hour, and between 25 and 75, we kind of have to imagine filling in those gaps, but between 25 and 75 would be 50. So we're doing 50 divided by 1, which is just 50. So y equals 50x. Okay. Now the last one says the point 1, 50 can be found on the graph for Gabe's car. Explain the meaning of the point in the situation. I know points are always x and then y, and if I look at the graph, I can see that x is hours and y is miles. So the point 150, I just have to connect these numbers with these units. So I'm just going to say in 1 hour, 1 is in the x position, which is hours, the car goes 50 miles. Again, just looking at which number is in the x or the y spot and then lining up the units. Okay, for the rest of this lesson, I want you guys to always be looking back at your key points. Really, the only operation you're going to have to do is division. So any type of problem, whether it's a unit rate or a constant proportionality, you should have some division somewhere on your paper. And then if we think back to these questions we just covered for is it proportional, you need all of your individual rates to match. If they don't match, if there's one number that doesn't work, even if it's just one, it's not proportional. That's what happened with Harrison's car. Okay, so be looking at that key point. If you're not sure, check, this is unit 5 in your binder. So you can also be looking at unit 5 notes or 5.12 daily practice. That's when we made our review guide and had a bunch of key points. So good luck with today's lesson. Look back at your notes if you're not sure. You got it.